I'm going to do another video about data, and today we are going to be focusing on another type of graph. This graph is called a line plot. So, as you can see over here, this is an example of a line plot. So, a line plot, pretty much just like the name says, it's a line. As you can see, it's a horizontal line from side to side, and the data is plotted right on top of the line. And our data over here is being represented by these X's. So to read this line plot, we're looking down here, which says years old, and over here these captions tell us exactly what these X's on top of the line plot mean. So over here it says 2 puppies are 1 year old, 1 is 3 years old, and 1 is 5 years old. So what this line plot is talking about is that there are puppies, and what they wanted to take data on is how old each of these puppies was. So 2 of them happened to be 1 of them was 3, and 1 of them was 5. And so that's where we get our ages, our years old down here. And this is how many puppies were that age. So 0 were 0 years old, 2 were 1 years old, 0 were 2 years old, 1 was 3 years old, 0 were 4 years old, and 1 was 5 years old. And if we wanted to see how many puppies they had taken this data on, we can just count up all of our X's. So that would be 1, 2, 3, and 4. And we can also count our puppies down here just to verify if we were correct or not. And you could see there's 1, 2, 3, and 4 puppies. So there was a total of 4 puppies. And from these 4 puppies, they wanted to see how old each one was. And that's how they graphed their data on this line plot. And they saw that 2 of them were 1 year old, 1 of them was 3 years old, and 1 of them was 5 years old. So this is just an example of a line plot, and we are going to be practicing more with this line plot throughout this video. So let's move on. So this line plot, very similar to our last one, it's about how old kids are who joined an after-school program. So as you can see over here, it's the same line side to side, and our data is plotted on top of the line in the form of these X's. So the numbers here, 5, 6, 7, 8, 9, 10, 11, 12, and 13, those are the years old, just like in my example right over here, years old. So over here, we have the ages down here from 5 to 13, and the X's represent the students that are that age. So, for example, we're just going to read through this just so that we have a better understanding. 1 student is 5 years old, 0 are 6 years old, 3 are 7 years old, 0 are 8 years old, 2 are 9 years old, 0 are 10 years old. We have 1, 2, 3, 4, 5, 6. 6 are 11 years old, 4 are 12 years old, and 3 are 13 years old. So that's how we would read our line plot here. So we're going to look at the question that is related to this line plot. So by being able to read it correctly, we can answer our questions correctly. So our first question says, what is the least, so least means smallest, what is the least number of kids that joined an after-school program? So if we are looking on our line plot over here, we can see that the least, or the smallest number would be 5 right over here. So there was only 1 5-year-old who joined an after-school program, and compared to all of our numbers that are plotted, 1 is the smallest. Now the next question says, it's the opposite. What's the largest number of students who joined an after-school program? So The largest, we're looking to see the greatest or the biggest number of students that joined an after school program. And we can see right off the bat from our graph that right over here we have the most X's stacked on top of each other. And we have 1, 2, 3, 4, 5, 6. So we have 6 11-year-olds that joined an after school program. And 6 compared to all of our other numbers here that are plotted on our line plot, 6 is the greatest number of them all. Okay, so moving on over here, this question says, what is the difference between the largest age and the smallest age? Okay, so difference is a key word for subtraction. So our largest age, what's our largest age that we have here on the graph? And we can see that the biggest age that we have is 13. That's our biggest age. And the smallest age is 5. So there are only 3 kids. Sorry about that. There are 3 kids that are 13 years old, and there's only 1 student who is 5 years old. So if we subtracted the amount of students, that it would be 3 minus 1, as I have over here, and the difference of that is 2. So we just subtracted the amount of students who were the oldest and the amount of students that were the youngest. And we subtracted that number. We got 3 minus 1 is 2. Okay, this next question asks, how many students are older than 10 years old? So we need to see how many are older than 10. So we're going to see over here, this is our 10. And if we look down here, all of these students are younger than 10. 9, 8, 7, 6, and 5, those are all smaller than 10. So what we're looking for is in the direction of to the right, we're looking at 11, 12, and 13, because those numbers or those ages are bigger. They're greater than 10. So there isn't over here any on 10, so we're going to start from 11, and we're just going to count the number of X's, which represent the number of students, like I said, and we're just going to get a total. So over here, we are looking for, we are adding. So we have 1, 2, 3, 4, 5, 6 11-year-olds. We have 1, 2, 3, 4 12-year-olds. So if I did 6 plus 4, that's 10. And then I have 1, 2, 3 13-year-olds. So 10 plus 3 is 13. And that's how I got this answer over here. So I'm looking for students who are bigger than 10. So remember, I'm going to look to the right, 11, 12, and 13. Those numbers are all bigger than 10. And all I did was I just counted the X's to get my total of 13. Because the X's represent the students. Now, over here, this is asking how many students joined after school total. So we're looking for the entire total here on the line plot. So what we have to do is add as well. So we're adding again over here. But we are adding all of the X's because we need a total of all of the ages that joined after school. So I'm going to start over here. So we have 1, we have 0 here. We have 3, so 1 plus 3 is 4. We have 0 here. Then we have 2, so 4 plus 2 is 6. Okay, we have 0 here. And then we have 6 here. So we have 6 plus 6 is 12. Then we have 4 here. 12 plus 4 is 16. And then we have 3 here. 16 plus 3 is 19. And that's how I got this answer right here. So to get 19, all I did was I added all of the students, and remember that the X's represent students, so I added all of the students, which is all of my X's that were plotted on my graph, and that's how I got my total number. Now over here, in my last examples, we were reading a line plot. We were answering questions that were related to line plot. But now we're given a table of data, and we have to create our own line plot now. So we have student and laps ran. So we have student 1, 2, 3, 4, 5, 6, 7, 8. We have 8 students, and we have all of the laps that they ran. So usually you're running laps in gym, where you're running around a field. So this student ran 12 laps. This student, number 2, ran 13 laps. Student 3 ran 12 laps. Student 4 ran 11 laps. Student 5 ran 7 laps. Student 6 ran 13 laps. Student 7 ran 11 laps, and student 8 ran 12 laps. And as you can see here, a lot of them ran similar laps, like student 1, 3, and 8. They all ran 12. Student 2 and 6, they both ran 13. And student 4 and 7 both ran 11, and only student 5 is the only one who ran 7. No one else ran 7. So a lot of them ran similar laps. So now that we have this table, we are going to graph or plot our data on top of our line. So as you can see, like how we have our line side to side, okay, and we have our down here is the laps that were ran. So the smallest lap that was ran was 7. We have all the way up until 13. We just have an extra number here, 14. So we have 7, 8, 9, 10, 11, 12, 13, 14. These are all the laps that were ran. So going back to our table, how many students ran 7 laps? So I'm going to look at my table and see, oh, there's only 1. So on my line, I'm just going to plot 1x for 7. That means only 1 student ran 7 laps. Now, there are no students that ran 8 laps, so I leave 8 blank. Going back to my table, there are no students that ran 9 laps, so I'm going to leave 9 blank. And there are no students that ran 10 laps either, so I'm going to leave 10 blank. Now for 11, I'm going to count to see how many students ran 11 laps. And I'm going to look at my table and look for laps ran. I see there's 1 and 2. So 2 students ran 11 laps. So I just represent that by 2 X's, 1, 2. Now going for 12. Going to count how many students ran 12 laps, and I can see there's 1, 2, 3. 3 students ran 12 laps, and that's shown over here by 3 X's. And then for 13, we have 1, 2. So 2 students ran 1, 2, 13 laps, and none ran 14, and we just leave that blank. So that's how we create our line plot. All I did was I created my line from side to side. These numbers from here, from 7 all the way to 14, represent the laps that were ran. So just wrote down these numbers, and the X's that are plotted on top of my line represent the amount of students that ran those laps. So only 1 student ran 7, 2 ran 11, 3 ran 12, and 2 ran 13. And I got that information from my table over here, which tells me I was looking to see laps ran, and I saw that only 7 was listed here. There was 1, 2, 3 12s. There was 1, 2 11s, and there were 2 13s. So that's where I got my numbers, and I used those numbers to have my data plotted here on my line. So that's how I created this line plot. And it's, sorry about that, that's how easy it was. I just went back, referred to my table, and used how many I saw from my table, and the students are represented by the X's. So only one student ran 7, 0 ran 8, 9, and 10, 2 ran 11, 3 ran 12, 2 ran 13, and 0 ran 14. So I'm hoping this was helpful in understanding what is a line plot, how does it look like, and how do we read it. So in this last slide that I have over here, it's a practice for you that you can try at home. So this line plot, it's about the number of stuffed animals that students have. So my numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, those numbers represent the stuffed animals. So the X's, as I have listed right over here, represent the students. So 1 student has 1 stuffed animal, 0 students have 2 stuffed animals, 2 students have 3 stuffed animals, 0 students have 4 stuffed animals, 2 students have 5 stuffed animals, 0 students have 6 stuffed animals, 4 students have 7 stuffed animals, and 4 students again have 8 stuffed animals, and 2 students have 9 stuffed animals. So we have some questions that we have to answer related to this graph, to this line plot. And the first one says, what is the greatest number of stuffed animals that students have? So this is kind of a trick question because, or I'm sorry, not that. So the greatest number of stuffed animals. So the greatest number is the biggest number. So what's the biggest number that I have here on my line plot? The biggest number here would be 9. That's the biggest number here. So only 2 students have 9 stuffed animals, and 9 is the highest number here of stuffed animals that they could possibly have. That's where my graph ends, at 9. And then on the other end, I have what is the least number of stuffed animals that students have. So I'm going to go all the way down here to see what's the smallest number I have here in my my line plot, and that is 1. And only 1 student has 1 stuffed animal, and 1 is the smallest amount of stuffed animals that the students can have. Now I have what is the difference between the greatest and the least. So I'm going to see the greatest is 9, and 2 students have the stuffed animals of 9. And my least is 1, and only 1 student has 1 stuffed animal. So difference keyword for subtraction, I'm going to subtract my amount of students. So I have 2 from here, minus 1 from here. So 2 minus 1 is 1. And then my last question says how many students are there in total. So that's an addition problem. So I'm going to count all of my X's to see what's the total amount of students that we have represented here on this line plot. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 students in total. So I'm hoping this concludes the video, and I'm hoping that this was a good introduction to a line plot, what a line plot looks like, how do we read it, and how can we answer questions that are related to it. I'm hoping that you practice this skill at home because the more that we practice, the better that we become. So you will be having some work that's related to this, and I'm hoping that you find this video useful to complete your work.